Welcome to solverfy.
In this problem on the topic of oscillators, we have a mass that is resting on a horizontal frictionless surface and is attached at one end to a spring. The other end is fixed to a wall. We know the amount of work needed to compress the spring by 0.13 meters is 3.6 joules. And once the spring is compressed and the mass released from rest, it experiences a maximum acceleration of 15 meters per square second. Using this information, we want to find the value of the spring constant as well as the value of the mass. Now, the work done in compressing the spring is stored as elastic potential energy, and the compressed location corresponds to the maximum potential energy and the amplitude of the ensuing motion. So this work is equal to half Ka squared, which is the maximum elastic potential energy stored in the spring. And so rearranging, the force constant for the spring K is equal to 2 times W over A squared. And so this is 2 times the work done, 3.6 joules, divided by the amplitude 0.13 meters squared. This gives us a spring constant of 426, or take two significant figures, 430 newtons per meter. So that's the spring constant for the spring. Now, to find the mass, we can use the maximum acceleration, which occurs at the compressed location where the spring is exerting the maximum force. If the compression distance is positive, then the acceleration is negative. We know this force is a Hooke's law restoring force, F is equal to minus kx, which by Newton's second law is equal to m times a. This means that from here, we can find the mass m to be minus kx over a. And this is minus 426 newtons per meter times the extension or the compression of the spring, 0.13 meters, over the acceleration, which is given as 15 meters per square second. And so, calculating, we get the mass, the value for the mass, to be 3.7 kg.